Aloha mai kako. In this video, we'll be talking about test-taking strategies and techniques to solve the math questions on the PSAT 8-9 practice test number 1. Before we get started, let's start with a joke. Why don't you want to go trick-or-treating with vampires? Because they're a pain in the neck. All right, guys. So these are just, I'm just going to present some ways to solve these questions. There are many other ways, but I will solve these with a variety of techniques, and hopefully some of these methods will appeal to you. I'll probably present what I think are some of the more effective ones. Okay, let's get started. This is the non-calculator section, which consists of 13 questions, and you'll be given 20 minutes to do these, okay? So let's go through these. These are non-calculator. Number 1, one method that's very powerful when you're given a fraction equals a fraction, as in this case, a fraction equals a fraction, is to get rid of fractions, one method is to, as you may see from this, cross multiply. The most important thing about cross multiply is you must remember you're going to have this from this cross. You will set each of the crosses, the products of the crosses, equal to each other. And that is the most important part about this problem. Okay. If you start with an equation, you've got to end with an equation. So you have 4x equals 180. This way, either way, it doesn't matter where you place the 180. It could be on the left or the right. It's an equation anyway, so it's the same. Okay. And to proceed to solve this, we can divide both sides by 4. And x is equal to 180 over 4, which is 45. Okay, you can reduce this and take your time if you want. It's 90 over 2, which makes it easier to see that the answer is 45. So notice reducing is a big tip. Okay, another way you can solve this is to create equivalent fractions. So you have 3/4 equals x over 60. In order to create equivalent fractions, we've got to have multiplied 4 by something to get 60. That multiplier is times 15. And if you multiply the bottom by 15, you should multiply the top by 15 as well to create an equivalent fraction. And that confirms the answer is D, 45. Okay. Number 2, there's many ways we could understand this problem. One way is to draw a graph. And we can possibly start with that. We can start with a quick graph. Obviously, no graph paper will be supplied to you, but you can always make your own. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it goes through 1, 5, which is there, and 2, 7, which if you get into this pattern, you can see that it's going to higher, 3, 9. And it is a line that goes a little something like this. Okay, I'll change color. Okay, and so if you look at this line compared to these equations, all of these equations are in what we call slope-intercept form, y equals mx plus b. Okay, and this is the slope, and this number represents the y-intercept. Okay, so if you look at this graph, obviously the y-intercept is 3, and so that only narrows it down to choice A. So A is the right answer, and notice it also has a slope of 2. Okay, if we go and look up close, here we see we went up 2, 1, 2. That's the rise with a run of 1. Okay, we went 1 across. We can also see this slope pattern from the table as the x's increase by 1. As the x's increase by 1, the y's are going up by 2. Okay, and that is the essence of slope. As you increase, and taking a look at the graph again over here, as x increases by 1, the y goes up by 2. So you have a rise of 2 and a run of 1, which gives you a slope of 2. That also confirms that A is the right answer choice. Okay. One trick is with tables. To get the y-intercept, you can take your table, and a good tip is to move backwards with the table. So if you move backwards, back up 1 step, okay, this would have been 4, 3, 2, 1 into 0. This would be 11, 9, 7, 5, 3. And 0, 3 also confirms that 0, 3 is the y-intercept. Okay, when x's are 0, the y value that you get is the y-intercept. So that also confirms A is the right answer choice. The overkill method for this is to actually get the equation of the line. Okay, and I think this, I would not have employed this technique for this because we already said the answer is A through those variety of methods that are much quicker. But just to show you, these are all points. Okay, it's important to understand these are points. These are ordered pairs, and they could be written like so: 1, 5, 2, 7, 3, 9, and 4, 11. These are points on a coordinate plane. Now, this method is very general, but very powerful. It's writing the equation of a line through 2 points. You can use any 2 points you want. Just for convenience or just being arbitrary, I'm going to use these 2 points. Okay. The first thing you have to understand is to write the equation of a line. To write the equation of a line, you need 2 pieces of information, which is the slope and a point, or a point and a slope. Okay. Notice we have a bunch of points, but we do not have, you guessed it, the slope. So the first thing we're going to do is find the slope. That's the change in y over the change in x. So the slope, as we discussed, is 2. At this point, for this question, we can automatically have chosen the right answer because there's only one equation with a slope of 2. But we're going to continue with this method. Once you get the slope, you will choose a point. I'm going to choose, for convenience, how about just, it could be really any point, but we'll go with 1, 5. Then you want to use point slope form, which is this. Okay. This formula is your template, and you just start plugging and chugging. So we got y minus 5, which is the y value from here. Okay. And you just proceed, equals m, my m is 2, that's the slope, x minus 1. Now this doesn't look like any of the equations, but what we have to do is transform this into slope-intercept form. The first thing you're going to do is distribute, and last add 5 to both sides, and you will get y equals 2x plus 3, which is answer number A. Okay, good. Number 3. This involves setting up a system of equations. You have X tickets at a cheaper price. Let's say you sell those first because airlines want to sell as many seats as possible. They don't want to make their seats super expensive at the start, or else they might not sell any. They run the risk of not selling any. So they sell X tickets at $90 each, and they sell Y tickets at $250 each. Okay, so X is the number of cheap $90 tickets. Inexpensive, I suppose is the word. Y is the number of expensive, more expensive $250 tickets. Having a key is a good strategy for writing for any system, any problem involving a system of equations. Okay, so when we're trying to build our system of equations, we just simply look. The airline sold 120 tickets, so this can create an equation. This implies an equation, which is X, the number of $90 tickets, plus Y, the number of expensive tickets. Okay, the number of cheap tickets plus the number of expensive tickets is 120. If you look at the answer choices, that only leaves A and B as possible answers. Okay. So if we were building our equations from scratch, this would have been X plus Y equals 120, which again means the number of $90 tickets plus the number of $250 tickets is 120, because it says there's 120 tickets total sold. The next equation will involve money. Okay, the money you bring in. We collected a total of 27,600. So if you sell one cheap ticket, you will get $90. So to make that true in an equation, you have to do that. Now, how does this simple expression work? If we sell one cheap ticket, we get $90. If we sell 2 cheap tickets, we get 180. And that's the essence of why we want to multiply these 2 quantities. Okay, but that's not the only way we can make money. We can also make money from selling the more expensive tickets. And that's how much money we would get in by selling a Y number of expensive tickets. Okay, if you sold one, you get $250. If you sold two, you'd get 500. And the total amount of money we brought in was 27,600. And this leaves the correct answer of A. Okay. This is a great question, I thought, by the College Board. Typically, when you factoring a trinomial, quadratic trinomial is reverse FOIL. FOIL involves multiplying if you're given a binomial. Let's say it's x plus a times x plus b. FOIL, this process of FOIL, F-O-I-L. F stands for first. This is first. This is outside, inside, and last. So when you multiply a binomial, you will get four terms, possibly, and you might need to combine at the end, but we're going to multiply the first. That's this guy and this guy, so that's x squared. Then we multiply the outsides. That's this guy and this guy, including that sign. Okay, so we'll have plus bx. And then the insides are these guys, including that sign. Okay, so that'll be plus ax. And these are the lasts. These are the lasts. Okay, so that's plus AB. So that's how we FOIL. Reverse FOIL is basically the idea of factoring. So when you have to try to factor this, this has to be x and this has to be x because these two multiply to get you x squared. Now, if you have gotten that far, the idea is this number times this number will get you this constant. Okay, so we're basically, that's how you narrow down your search for getting these numbers that appear in each binomial. You need to look for two numbers that multiply to 60. Okay, so the numbers that multiply to 60 are 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, and 6 and 10, and 7, 8, 9, 10. Those are all the factors, okay, in pairs. Now, two of these possibly add or subtract to negative 17 in the middle. Okay, that would be this one and this one. The way we have to choose this, we have to understand though that, notice both those numbers, 5 and 12 and 3 and 20 appear in the answer choices. So the way you narrow this down is this. One way is you have to understand this constant is a negative. You can only get a product that's negative from multiplying a positive times a negative. That rules out using this number pair because then we'd be adding or subtracting 5 and 12. Okay, so that eliminates A and B. If you FOIL these, for example, okay, you would get x squared minus 17x plus 60, which does not match this. Okay, the constant term and this will be a positive. The constant term that we need of our expression that we need to factor is a negative. Okay, this is closer because this will, if you FOIL this, you will get x squared minus 7x minus 7x minus 60. So you will get that negative constant, but this middle linear term doesn't match this, okay? Which is why that would be wrong. So if you had to factor from scratch, if you're understanding, we're back to here. You need the negatives dominate, so you need the larger number, the negative to go with the larger number. That's we're using this combination here, and this should be 3, which is answer choice D. Okay, if you FOIL this out, you would get x squared minus 17x minus 60, which does match this. If you FOIL this out, just for kicks, you would get x squared minus 23x plus 60. Again, the constant is a positive, which is not what we want from here. So that's why C is not the right answer choice either. The right answer choice is D. Okay, and that's a little bit about how you factor a quadratic trinomial. Number 5. You have a graph, so the idea is you kind of need to match it with the right equation. The thing about this, similar to the number 2 that I discussed, is these can be written in slope-intercept form. And as a matter of fact, they are all in slope, and this is the intercept. What intercept? The y-intercept. So if you want to look at the graph, you see that the y-intercept is 3. That eliminates A, and that eliminates C, and that leaves you possibly B and D. Okay. You would then look, the only distinguishing factor between these two is that the slopes are, they have different slopes. They're both negative, which is correct. This is a negative slope. You can think about that. If you draw capital N, that's one way you can think about a negative slope. So both of these are negative, and if you choose any 2 points on this line, for example, there and there, you would you could either go from there to there, from this left to right, and bottom to top, in which case the rise would be 1, 2, 3, a rise of 3. The slope is a rise of 3, and you go left 1, a run of -1, since you went left, and this is a slope of -3, which does lead you to the right answer of B. Okay, if you happen to go down, this would be a rise of -3 and a run of +1, which is still a slope of -3. Okay, and that makes sense intuitively just looking at that. A slope of -3 is rather steep. A slope of -1/3 is rather flat. Okay, it is close to a slope of 0, which is a horizontal line. This is a line with a slope of -1/3. You can see it's negative, just like a capital letter N. And you would go down 1 and across 1, 2, 3 would get you a slope of -1/3, and that's just a rough sketch. Okay. And so as we discussed, this is not the right answer. It is B. Here, we are just simplifying this expression, so combine like terms. My biggest piece of advice is that the sign travels with the term. Please notice I'm now breaking these out of parentheses. -11x plus 31y in parentheses is still, as a group, -11x plus 31y as a group is -11x plus 31y. Okay, you need to write this without parentheses. This distributes, including that sign, including this -2. Okay, so when you distribute, you will get plus 2x minus 10y. And combine like terms, including the sign, okay, because you got to know what to do. That's my biggest hint to you guys. Sign travels with the term. There's -9x. And you combine this guy, positive 31y minus 10y, so that's plus 21y. And that is -9x plus 21y, C. Okay. Moving on. 7. This is a formula from physics, and all the other words are just pretty much explaining what these letters represent. So all that it is saying is that this is a true formula from real life that actually works. What's important though is that which formula represents H. In short, we just need to look at the formula and solve for H. Okay, so all the rest are there to just not necessarily distract you, although it can be distracting, but it's just explaining what each of these variables mean and indicate. So to solve for H, we need to get H by itself. We always move terms first, so we're going to subtract S from both sides. P minus S is going to be dgH, and you divide both sides by dg. Why do you divide both sides by dg? Because dg and H are linked through multiplication, so you need to break that bond through division. Furthermore, dg by dg, I'm not talking about H, but dg divided by dg, anything divided by itself is 1. So that leaves you 1 H on the right, and the answer P minus S over dg on the left, which is answer choice B. Okay, and those are literal equations. This formula will simplify to C equals 0.19x plus 1,000. The 1,000, if you read the problem, is the amount for insurance. This is the amount you pay for insurance, okay? Which is what you have to pay for a car, no matter if you drive a lot or not drive at all, okay? Your car just has to be insured to be on the road, to be allowed on the road. X is the number of miles driven, and number of miles driven in a year, X, number of miles driven in a year. And 0.19 is the sum of the maintenance and the fuel, okay? As we see, that's where these numbers came from. That's maintenance per mile, and that's fuel per mile, okay? And C is the total cost of operating and owning a car within a year, okay? So this question is asking for what is the slope of the graph. Since this is basically in slope-intercept form, if you recognize that, guys, this is in y equals mx. I'll write it above, y equals mx plus b form. This slope corresponds to that number. So they're asking what is the significance of what's the slope of the graph of this function, which is 0.19. What's the significance of this number? Okay, and it is not the cost of insurance for a year. It's not A, because that's 1,000. It is not the cost of fuel and insurance for a year. The cost of owning and operating per mile, that's kind of close, okay? C is the cost of owning and operating the car for a year. I wouldn't say it's the cost of owning, okay? It's more the cost of operating per mile, because we need to pay for maintenance and fuel. So that's about operational costs. The only reason why D, I think, is the much clearer choice is that it's very specific. It is the cost precisely of maintaining your car plus the fuel per mile. Okay, it will cost you 19 cents per mile in maintenance and fuel to drive. And that's the significance of this slope. Okay. If we graph this equation, it would, if we sketched it at least, it would look like this. Okay, where this is X, which represent miles, and this would be dollars. This right here is 1,000. So what does this graph show you? No matter if you drive or not, it will cost you $1,000. The reason why the cost goes up, sorry, this is cost as measured in dollars. The reason why this cost goes up is because we are driving miles. So with each and every mile we drive, it has a certain cost associated with via maintenance. We have wear and tear on the car, and we also need to pay for gas. And that's why it's going up by 19 cents for every mile that we drive. Every mile we toggle to the right, we go up 19 cents. Okay. This is similar to simplifying. The first thing we have to do is break everything out of the parentheses, but this is an equation. So we have negative 4x plus 5 minus 6x minus 7 equals 0. The thing I tell my students is you always want to simplify before you start moving things around. I liken this to if you know you don't need some things, if you're about to move houses, you want to have a yard sale first. You want to simplify your life, then move to your new house, okay? So you want to simplify things first, consolidate like terms, and this is negative 2 equals 0. And then now this probably looks a lot simpler to our eyes, and we're just going to go ahead and solve that, get x variables to one side, numbers to the other. So we have negative 10x equals 2 after you add 2 to both sides. And we're going to divide both sides by negative 10. And you have an answer of x equals negative 2/10, which is negative 0.2, negative 0.2, 2/10. That's exactly how we'd say that. Okay. And so the right answer choice is C. Okay. This question relies on a few different techniques. We could generalize about volume. Okay, volume exists in 3 dimensions. So we have to talk about 3-dimensional objects. Volume is proportional to, in this case for a sphere, volume is proportional to r cubed. Now, this is not an equal sign, because if it were, I would need the other constants, namely that volume of a sphere with radius r is equal to 4/3 pi r cubed. Okay, a proportional statement just says it changes the equation into a proportion, and it ignores the constants. Okay, and so it just says that it will grow according to a cubic function, not the exact cubic function, but a proportionality says it will grow according to a cubic function. So this is basically a simplified version, and the easiest way to think about this problem is consider if r is equal to 1. If the radius is equal to 1 for this, then the volume would carry a value of 1. Okay, it would, for all intents and purposes, be equal to 1. And if you double the radius, for example, you make it 2, you're going to plug in a 2 here, and you're going to cube it, and so now the volume will be 8. So doubling the radius simply increases the volume by a factor of 8. By how many times will the volume be bigger? So the right answer is D. Okay, and that involves an understanding of proportionality. If we had to talk about the equation though, here it is, V equals 4/3 pi r cubed. Notice in this problem that some students may get bogged down by them saying, hey, the radius is twice the radius of the smaller one. They might say, well, what is the radius? And that's kind of the point, okay? It doesn't matter. So if we chose a radius of 1, let's suppose the radius is equal to 1, the volume of that sphere would be exactly 4/3 pi times 1 to the third, which is just 1. So the answer is 4/3 pi. If the radius is 2, we would plug in 2 here. And notice how I'm writing this. I'm not going to simplify it. My volume is 4/3 pi times 8. So you can clearly see this quantity is basically 8 times of this. Why? Because there's 8 times of this same exact element. Okay, same exact set of symbols. So the volume of this radius, which is twice as large as this, the volume would be 8 times larger, which again leads us to the answer D. Now you might be wondering, wait, Kumo, no one said the radius is 1 and then you double it and it gets 2. True, but what I'm going to share is it doesn't really matter. Okay, let's suppose you went the same volume formula, 4/3 pi r cubed. Obviously, this is a non-calculator section, but I will show you that the radius does not matter. We're going to pick a radius, an arbitrary number. Let's say 4. Let's say 4. That's nice and arbitrary. And the new radius will have a new radius of 8. So this volume will be 4/3 pi times 4 cubed. Okay, 4 times 4 times 4 is 64. Okay, 4 times 4 times 4. I can double check that. Okay, bring up the calculator. 4 times 4 times 4 equals 64. Okay, so yes, that's 16 times 4. And here, over here, I'll have V equals 4/3 pi times, I need to cube 8. Okay, I'm going to plug in 8 and I'm going to cube it there. So it'll be 8 times 8 times 8. And I'll go on my calculator, I'll go 8 times 8 times 8. And I'll have 512. Okay, 512. This number is how many times greater than that number? Well, one way to do that is just do 512 divided by 64. And I hope you see 64. And that will equal 8. So as you can see, it does not matter what the radius is. This will always be, if you double the radius, this will always be 8 times greater than that. In compared in their volumes. Okay, moving on. These are the open-ended questions. Okay, this is a fun question. If the equation of y equals 2x squared minus 5x plus 3 is graphed in the xy plane, what is the value of its y-intercept? You don't actually have to graph this. Okay, and that's the point. But its graph will be a parabola since it is quadratic, if you wanted to know. But here's the thing. I like to draw this little mascot to help me remember how to find x and y intercepts. This is our good friend, the he'e. And yes. Okay. If you notice, these are, oh, that's interesting. These are the x-intercepts, which we are not concerned about. And these are the y-intercepts, which we happen to be asking for in this question. Okay, and this graph is really helpful to me. I draw it all the time because it reminds me to find x-intercepts, which are this, this, and this. They have something in common. What do they have in common? Their y is equal to 0. So you set y equal to 0. Here's the strategy. You set y equal to 0. And since we're solving for x-intercepts, you will solve for x. Now, if that's the case for x-intercepts, it must be the opposite for y-intercepts, and it is. But I'll explain why. These are the y-intercepts. Notice that they all lie on the vertical line, x equals 0. And their x value is 0. So you set x to 0. And you simply solve, since we're finding y-intercepts, you solve for y. And I hope that makes a lot of sense. So given this equation, y equals 2x squared minus 5x plus 3, y equals 2x squared minus 5x plus 3, we are simply going to set x to 0. If you plug in a 0 there and a 0 there, those terms will become 0. because if you square 0, it will be 0. And if you take 0 times 2, it will be 0. And negative 5 times 0 is 0. Okay, so all you're left is y equals 3. And that is the y-intercept. So what is the value of the y-intercept? You would record 3 in the open-ended answer sheet. Okay, and let me see if I can erase these guys. Great. Okay. Moving on, number 12. Systems of equations. There are 3 ways to solve systems of equations. They are graphing, substitution, and elimination. It depends on your preference. This can be done by substitution or elimination. I might as well show both. So here we go. 1, 2. If you're going to use substitution, the thing is, the first step is you have to get one of the variables by itself. If you look across God's creation, this, the easiest variable to get by itself is the y from equation 1. So I like to number my equations because it's easier to refer to. This is still equation 1. And if you solve for y, you would subtract 3x from both sides. This is still equation 1. Okay, y equals negative 3x plus 13. Remember, a sign travels with the term. This goes in front, and that negative has to stick with it. And there's a positive 13. Okay, so I have rewritten equation 1, y equals negative 3x plus 13. What you're going to do now is you're going to take this expression for y, how substitution works. You're going to take this expression for y and plug it in to equation 2. Of course, you can't plug it back in equation 1. You're just going to get a true statement. You're going to plug it into equation 2 for that y right there. Okay? So we're going to write equation 2. How I like to notate this is 1 going into 2. And it will look like this. Please note, the form of this equation is basically equation 2, but I'm going to leave a space where y was, okay? This was where y was. And in the place of y, I'm going to write this. Because why? Because it's equal to y. Because this is equal to y. Okay, so I'm going to plug, instead of writing y, I'm going to write negative 3x plus 13. Why would we do that? Notice, guys, there are only x values in this problem, okay? Only x variables, sorry. So we can solve for that. This is 2x plus 12x minus 52 equals 18. You want to consolidate before you start moving. 14x minus 52 equals 18. We can add 52 to both sides. And we get 14x equals 70. And you divide both sides by 14. And you will get x is equal to 5, which is all they're seeking. They just want the value of x. Okay, let's solve this system of equations via elimination. So I'm still going to start out, number my equations. For an elimination to work, guys, you must have either the x's matching, in a sense. Matching is a general term for being the same. Opposites are okay too. Okay, or you need the y's, y coefficients and variables matching. Okay. I think the majority of students would choose elimination for this. The reason why is because the x's and y's are aligned. They are in standard form. To get the y's to match, we're going to take equation 1 and multiply it by 4. That's my work for that. So that would be 12x plus 4y equals 52. We can do that because we're basically multiplying the left side by 4 and the right side by 4, and that's entirely legal. Equation 2, you're not going to change. And you come to this spot in this problem where you see, these are opposites. Okay, my hint to you guys for solving systems of equations is if they are if they're exactly the same, if the terms are exactly the same, we will subtract. That is how you eliminate. If they're opposite, we will add. That makes sense, okay? To get these y's to be eliminated, we are going to add equation 1 to equation 2. Okay, this is equation 1 plus 2. I like to put a big plus sign there to remind me every operation has to go through that plus. Okay, so we're going to have 12x plus 2x. That's what gives me 14x. I have 4y plus negative 4y. Yes, that is what gets us 0. Okay, and I understand that simplifies to minusing, but you have to add everything else. Why? Because that is the operation we chose. 4y plus negative 4y actually gets us to no y. Okay, and we're gonna add these because that's what we chose, equals 70. And again, this is in a similar place as the last problem, so x is still equal to 5. Okay, let's talk about this question. Guys, we went bowling. Good game. 12 friends. They each had to rent shoes. They each rented shoes. So off the bat, they paid 36 for shoes. Here's my drawing of a shoe. Wonderful. 36 for shoes total. 4 friends bowled 2 games each. That's 8 total games from those 4 friends, 8 games. And 8 friends bowled 3 games. That's 24 games. So that would be 32 games everyone played. Okay. Each game bowled cost the same amount, and that's what they want, the cost of each game. So always look to the question for the unknown. We can call that, I don't know, we can call it any variable we want. Why don't we say G? Let's call it C, which represents the cost per game. If we had to make an equation, the total cost, we would get it from this equation. The total cost for shoes, 36, and plus the games bowled. Well, I bowled 32 games, but I don't know the cost, so that's where this comes in. If the costs were $1, I paid $32 because I played 32 games. If the costs were $2, I paid $64 because the cost is, I'm sorry, if the cost was $2, I would have paid $64 because I played 32 games. That's how this equation is working so far. I haven't written the equation yet, but I will. This is cost for shoes, this is the cost for games, and if we add those up, this is a total of $212. And this is the equation we need to solve. Okay, so we need to get variables to one side, numbers to the other. Here's our variable already. You're gonna minus 36 from both sides, and you will get borrow here. That goes there, 6. I borrowed 1, that goes here, 7, 6. Okay, 176. So 32C equals 176. At this point, to solve for C, you divide by 32. You can leave answers, guys. You can leave answers to the open-ended as an improper fraction, but it does need to be simplified. So I've got C equals 176 over 32. If you're not keen on long division, I recommend you just keep simplifying this. They're easy. Both these are divisible by 2. They're both divisible by 16, I believe, but let's just go divisible by 2. We don't have a calculator, so 88 over 16, divide by 2 again, 44 over 8, divide by 2 again, 22 over 4. And notice these numbers are getting smaller and should be easier for us to simplify. 11 halves is perfect. You can record that answer, and this is also equal to 5.5, 5.5. So it will cost, so what does C represent again? C is the cost per game. Okay, and that concludes the no calculator section. Guys, one tip for open-ended: if you get a negative answer, something went wrong. Okay, notice all these answers are positive and 5.5. Okay, the open-ended questions on PSAT, bubble in your own questions, are never negative. They have that instruction in instruction number 3 on the page for open-ended bubbles. Okay, thank you, everyone. All right, everybody, let's continue with the calculator section of the PSAT 8-9 practice test number 1. We'll go over solutions and strategies and techniques to solve these questions. Before we begin, let's start with a joke. What do dentists call x-rays? They call them toothpicks. All right, thank you. Let's begin. Question number 1. Remember, this is the calculator section. It consists of 25 questions. You will be given 40 minutes to complete 25 questions. Always pace yourself. Always look for the lowest hanging fruit. The questions you do know how to do, try to do those first. Don't run out of time. Okay? All right. Let's take a look. Carissa ordered 3 cans of lemonade for each person at her party. She also ordered 1 pizza for every 4 people. If they ordered 6 pizzas, all right, so let's take a look. There we have 1 pizza per 4 people. Okay, You could start this proportion with words. To make that look simpler, I will do that. Pizza to people. And the top number will represent pizzas, and the bottom number will represent people. She ordered 6 pizzas. So where would you put the number 6? Since it represents pizzas, would you put it on top or bottom? Well, look, good thing we've got our handy dandy code over there. So we're gonna put pizza on top. And we wanna basically know how many people they brought. So we could call this X, we could call it anything. Like you learned from section 1, a very powerful technique to solve equations involving fractions. So if you have a fraction equals fraction is to cross multiply. So we've got X is equal to 24. What does X stand for? The number of people. So there were 24 people at this party, and was just following, you could represent the number of cans of lemonade. Remember, she orders 3 cans per person. And if there are 3 cans per person, 3 cans per person, that's a lot of beverage, by the way. But there's 24 people, then how do you find the number of cans is to take 24 and multiply by 3. And there's a calculation section, but we don't need that. So the answer is D. Correct. Okay. And let's move on. Number 2. A bakery sells trays of cookies. Each tray contains at least 50 cookies, but no more than 60. So it's looking at 50 on the low end and 60 on the high end, each tray. And it's in a range of here. Which of the following could be the total number of cookies on 4 trays of cookies? Okay. So if 1 tray contains this range, then 4 trays, you're going to take each of these and multiply them by 4 to find the range. That would be 200 on the low end of number of cookies, and we'd have 240 on the high end. So you look at these numbers, psat's a range from low to high. Only one of these numbers is in the range from 200 to 240, and that is B, 205. So that's the right answer. Okay. All right. A survey taken by 1,000 students at the school asked whether they played school sports. This idea of a proportion is going to be really important for a lot of questions in this section. So please try to understand that concept. Okay, and I'll have multiple opportunities presented. But anyway, a survey taken by 1,000 students asked whether they played school sports. The table below summarizes 1,000 responses from the students surveyed. So these are all disjoint. You either play a school sport or you don't. Those are your 2 choices. There's nothing in between. And so the males who play at a sport, plus the males who don't play a sport, plus the females who play a sport, plus the females who don't play a sport, should all add up to 1,000. So you would take your calculator and do 1,000 minus 312 minus 220 minus 216. See if I can remember those when I switch to my calculator. Let me jot these now. 32, 220, 216. Okay, so you're gonna grab your calculator, which is this screen, and you have that should represent the entire 1,000 students of the student body. Minus 312 minus 220 minus 216, and you get an answer of 252. Okay. And so that leads you to answer choice B, which is the correct answer. Okay, 252. Basically, the understanding that all of these numbers in these boxes should add up to the 1,000 students who are in the school who were surveyed. A waiter receives tips from each customer. On average, the tip is 15% of the customer's bill. Okay. At this rate, which of the following is closest to the tip the waiter can expect when a customer has a bill that's $78.20? So if you order food and drinks for $78.20, it is customary and polite for good service to tip 15% or more. And how we calculate tip is you take that subtotal and you multiply it by 15%. The thing is, on a calculator, whenever you're using percents, you must convert to decimals. So we're going to multiply this by 0.15. And that will be the tip amount. This will only be the tip. That's not the total you're going to pay. At this rate, which of the following is closest to the tip? That is what they're asking for. Okay, so you take 78.2 times 0.15, 78.2 times 0.15, 78.2 times 0.15, and you will get 11.73. 11.73 is closest to 11.73. It's kind of close to $10, but it is much closer to $20. Okay, it's only 27 cents away from $12. So the right answer is C. Okay, moving on. Number 5. Temperatures. Shows the high and low temperatures in Houston, Texas during a 5-day period. So here's your 5 days: Monday, Tuesday, Wednesday, Thursday, Friday. Those are the highs tracking, and those are the lows tracking. Okay. So here's what they're asking for. What is the mean low temperature? The mean, we have to understand, is the average. Mean is the fancy math term for average. While we're talking about it, the median, might as well. This is the middle number in a set. Middle number in a set. And the set has to be arranged from least to greatest. If you happen to have two numbers in the middle, two middle numbers, you have to take the average, the mean of those two numbers. And the mode, just so we're talking about these, there's the most occurring number, most frequently occurring number, most frequently occurring number. And the range is the difference between the highest and lowest. You take the high number in the set minus the low number, and that will provide the range. But mean is just the average of the low temperatures. So you're going to take these numbers, and we're going to go on our calculator to find the average. You're going to add up all the numbers and divide by how many numbers you have. So I'm just writing them down. So when I take a flip to my calculator, I will be able to add them. So I'm going to take 49 plus 37, ooh, chilly, plus 41, plus 54, plus 63, and that will give me 244, which is not the average. I still have to divide by the number of numbers I included in that set, which was 5, and I get an answer of 48.8. Okay, 48.8, which is answer A. Wow, they put B so close, didn't they? All right, so the right answer is A. And moving on, number 6. A random sample of 50 people. I think this is going to involve a proportion of 50 people from a random sample of 50 people from a town with a population of 14,878 were asked to name their favorite flavor of ice cream. If 7 people in the sample named chocolate as their favorite ice cream, how many people in the town would be expected to name chocolate? So these are people. You can set up a proportion, in many ways, but this could be choco lovers, and on the bottom we're going to have total people. Okay, technically there shouldn't be an equal sign there, but we can in a sense, and this is our proportion. When you write this, I know there's one too many equal signs, but you are going to be focusing on the numbers in this box because that is a true equation. This one is just guiding me, just keeping everything symmetric and telling me where the numbers go. So 7 people in the sample were chocolate lovers. So there were 7 chocolate lovers in a sample of 50, and that's important, okay? It's a proportion. That's about 1/7, roughly 1/7 of people like chocolate. So you need to find out how many chocolate lovers there would be out of a total population. This is total people. Okay, this is in the whole population now, 14,878. And this is the key to solving this problem. Okay, this is a fraction of about 1/7, and you need this fraction to be about 1/7 as well. And so, but we're solving it precisely. So this is an equation, like I said, whenever you have a fraction equals a fraction, a very powerful technique is to, you guessed it, cross multiply. 50x equals, okay? And we've got to get to a calculator, 14,878 times 7, okay? So we'll go on a calculator, 14,878 times 7. That will give us a whopping 104,146. If I go there, I remember I need to divide by 50 because that was 50x, okay? And I will divide by 50 while I'm on the screen, and that will give me 2,082.92 people. You can have 0.92 people, but we are going to they're asking about how many. Okay, so this was, by the way, this cross product was 104,146. Divide both sides by 50, and so you get X, which is, what does X stand for? The total number of chocolate lovers in the entire town would have been about 2,082.92, and that is close to answer B. Okay. All right, moving on. Proportions are very important, guys, and try to think about those techniques here. Okay, whenever you have a fraction equals a fraction, I recommend cross multiplying. Okay, and just remember it yields an equal sign. A study was done to determine a new car's stopping distance when it was traveling at different speeds. The study was done on dry roads with good surface conditions. The results are shown below, and it's a quadratic function. Okay, according to the model, which of the following is the best estimate for stopping distance if the vehicle is traveling 55 miles per hour? So you're going to look on this axis. This is roughly 50. Okay, smack dab in the middle. So if that's 50 and this is 60, then 55 is right here. You just trace this graph up to find the stopping distance. That's close to around here. And you toggle over with your eyes over here. That looks to me, without looking at the answers below, as about 220-ish. Definitely, your eye might go to 250. Okay, but 250 is up here, guys. It's close, but it can't be 250. So it's got to be C, 210. That would be the stopping distance. Okay. Moving on. A. Water in gallons used through two different types of shower heads after X minutes of use. So as X minutes are used for different shower heads, one uses this many gallons according to this model, and this uses this. This will have this many gallons according to this model. That's basically 2.5. This is the slope. Going back to the earlier section, this is the slope, and that should be gallons per minute. Okay, because X is minutes per use. So with every minute, to calculate the number of total gallons, you got to multiply by the rate. And so these are rates. But let's look at the answer choices. For each minute of use, the amount of water that flowed through type B is twice the amount that flowed through type A. That sounds pretty good to me. So I would consider that. I'll go back to it again. For each minute of use, the amount of water that flowed through type A is twice the amount. That is not true. Type A is more water efficient than type B. Okay. So B is not right. The amount of water that flowed through type A increased at a faster rate. They are not increasing, they are flowing at a constant rate. We know that because these are linear and the rate doesn't change. Okay, and D, the amount of water that flowed through type B per minute increased. Again, it is not increasing. The rate is not increased at a faster rate than the amount of water that flowed through type A per minute. The water that's flowing through type A per minute is at a rate, but it is not increasing. The amount of water that flowed through it is simply twice the amount that flowed through type A. You can consider that. Let's say we choose an arbitrary time. Let's say X is equal to 1 minute. Okay, that means the Y, the amount of gallons through A, would be Y equals 1.25. And the Y flowing through type B would be, we're plugging in a 1 there, 2.5. As you can see, this is double of that. Now you might be saying, why we don't need to choose 1. You're right. Okay, we can choose any arbitrary number. For example, X is equal to 4 minutes. Then for Y, it would be 4 times 1.25, which is 5 gallons. And this is from type A. And from the second type B, if we plug in a 4 there, shower head, we'd get 10 gallons. And again, that is still twice the amount. Okay. So we are looking at answer choice A. 8 is A. 9. The number of cubic yards. This is a good one. I think what can help with this, if you're not super familiar with the conversions, is to draw a picture. Okay. So this is 1 yard. 1 yard. It is broken up into 3 feet. They tell you these conversions. 3 feet. This is every 3 feet. Okay, I'm sorry. 1 yard is 3 feet, so this is a foot, this is a foot, this is a foot. Okay, 1 yard is 3 feet. So this is 1 yard from here to here, which consists of 3 feet. 1, 2, 3. Now each foot we know consists of 12 inches. So on the same diagram, you could do 12 inches. There's another 12 inches, and there's another 12 inches, but we might not need that. Okay, so the concrete will fill a space that is a right rectangular prism. Interesting to draw. We could do 42. This just helps keep our thoughts organized. This is 42 feet. This is 18 feet. And that height is a little much too high. It's not to scale though. It is 6 inches. So this is clearly not to scale, but it is just a way to organize my thoughts. 42 feet. All of these dimensions need to be converted to yards. Okay. So there are 42 feet. If you're unsure about this conversion, you can always use proportions. Like I said, feet to yards, always started with words. There are 3 feet to 1 yard. That is given. 3 feet to 1 yard. If you flip these, it would not matter either, okay? You could have yards on top and feet on the bottom. But anyway, I've got 42 feet and I want to know how many yards that is. Okay, so I create this and lo and behold, we can, we have a fraction equals a fraction and we can, you guessed it, cross multiply again. So 3x equals 42. You divide both sides by 3, so you get x is equal to 1, 4. That's 14. 14 what? That's 14 yards. So one of these dimensions is 14 yards. If you look at these answers, this eliminates C and D. These are not the right choices, so it could be between these two. 18 feet is, if you use the similar technique, you also know that 6 yards, so that doesn't narrow things down. It comes down to 6 inches. And how many yards that would be? Is it 1/6 of a yard? Is it half of a yard? So if you look at this handy dandy diagram, we've got 6 inches right drawn from here to here. That is 6 inches. Okay, this is 6 inches. Now, from here to here is 6 inches. Okay, this is a span of 6 inches. Now, compared to the 1 yard, this is the yard. Please note, this is 1 part out of how many? 1, 2, 3, 4, 5, 6. You see how this diagram can really help. 6 inches is 1/6 of a yard. Okay. Another way you can, it's certainly not half a yard. Half a yard is right here. That's 1.5 feet. 1 foot and 1/2 would be half of 1 yard. Okay, considering this, half of 1 yard. So we know that's not the answer. And that's one way you can visualize that. If you had to walk through that a different way, we can think about this. 6 inches, you can first convert it to feet as well. 6 inches is 1/2 of a foot. I can go decimals, 0.5 of a foot. And we might use this similar thing up here. Okay, that similar idea of this proportion. So we go feet to yards. The first number is the proportion itself, okay? And the scale, and the conversion, 3 feet to 1 yard. And I'm gonna put in 0.5 feet because feet goes on top. And all I want to, I'm basically finding yards. So I'm gonna cross multiply. I have 3x equals 0.5. And if I divide by 3, I'll have, this is probably easiest actually as a fraction. This 0.5 I'll rewrite as 1/2, and this is 1/2 over 3. 1/2 divided by 3 is 1/6. I can prove that another way. Dividing by 3 over 1 is the same as multiplying by its reciprocal. That's 1/3, 1 over 6. If I had to spell that out for you guys, that's 1/2 divided by, if I write it this way, 3 over 1. This problem right here is this. And I'm going to change division into multiplication. I have to change the multiplication and flip this number. So I get 1/6. 1/6 would be right here, and that's 1/6 of a yard. Okay, so that's technically how we'd find that, but we did use a diagram to think about that in a much more direct way. Number 10. Okay, the charges for a parking garage. Up to 30 minutes. So notice this is a discontinuous graph because it will jump. If you go from 30 up to 30 minutes, 30 minutes or less, you're going to pay $1. But if you just went a little over 30 minutes, meaning 30 minutes and 2 seconds, you are now going to be charged $2. So basically, we need a graph. We need a picture that goes up to 14. Okay, that eliminates this. That possibly leaves us this. That possibly leaves us this, but that eliminates these two. Okay, so we need to be able to charge $14. And now we need to get into some nitty gritty. Let's take a look. On the high end, we've got 180 up to 240, 180 minutes up to 240. Please note, this has no span. This graph doesn't even exist on that domain. Okay, and so that can't be the right answer choice. Between 180 and 240 minutes, that's in this band. And yes, you'll correctly pay $14. So the right answer is C. Okay, good. Moving on. Yes, just if I had to say anything more about this is parking time, and that's how much you need to pay. Okay. This is a very interesting problem. One very good, very powerful technique that isn't talked about much, I think, in ratios. Actually, maybe it might be talked about, but it's not shown in ratios, is to create an extended ratio. What do I mean by that? So this is silver to copper, and don't stop there. This would be the total. Okay, so you would go silver, 37, to copper, 3, and a total of 40. You're going to add those. Now, why would we want that? Because in this problem, they're saying the platter has a total mass of 600. This is a combination of the silver and the copper. So where would you put the 600? Would you put it here? Or would you put it here? Or would you put it here? You're going to put the 600 here. And at this point, all we have to do is understand the scale factor. So 40 multiplying by what gets us to 600 in terms of the total. And that number is, I believe it's 15, but I will take my calculator and check. I'm going to take 600 and I'm going to divide it by 40. Okay. So just this is to find the scale factor, 600 divided by 40. Now notice where did the 40, it's 15 times 15. Where did this 40 come from again? This was the combination, the total of these, the sum total, and it's creating an extended ratio. Okay. Which is handy because the ratio of copper to the total is 3 to 40. The ratio of silver to the total is 37 to 40. Okay, so if we multiply everything by 15, this also needs to be multiplied by 15. There are 45 grams of copper by weight, and 37 times 15, I will do that. So just to show you, 37 times 15 is 555, right? Okay, which does completely match. These are grams of silver, grams of copper, and total grams. As you can see, this plus this will be this. This also ensures that we retain the ratio of this to this will be 3 to 37. How do we know that? Because we multiplied both of these by 15. And we could just as easily take these numbers and divide by 15, and they would reduce to 3. 45 over 555 would reduce to 3 over 37. So they maintain the same ratio. They're asking for copper, and that would be 45 grams. The right answer is B. Okay. In my mind, that is the easiest way to do this problem. There are other ways involving a system of equations as well. We don't necessarily want to do that. Another idea is this idea of a scale factor. Let's call X is the scale factor. If you scale up 3 times X, so if you have silver to copper, and these would be amounts of mass of silver, mass of copper. If you call the mass of silver 37X, and you call the mass of copper 3X, That's not to say the ratio is going back. That's not to say the silver is 37 and copper is always 3. That's not always the case, because how can these two add up to 600? It is to say that the ratio of silver to copper is 37 to 3. If we multiply silver by X and the copper also by X, we could also, they will maintain the ratio of 37 to 3, because these X's will cancel if we were dividing both of them to find the ratio. These X's would cancel, which ensures that the ratio is still 37 to 3. So if the mass of silver is 37X, which it could be, and the mass of copper is 3X, we're just solving X, which is the scale factor here, okay? And that total, this is mass of silver, this is the mass of copper, okay? And it's gonna equal 600. So this is 40X, this is notice a very similar method. 40X equals 600. You will solve for X, which is 15. X is not the right answer, okay? Obviously it doesn't show up. X is only the scale factor. So you would need to still find out how much copper you're being used, and that would be down here. You're gonna take 15 and multiply it by 3 to find B as the right answer, 45. I think extended ratio is clearly the best way to do this problem. There is a system of equations method, not necessarily the cleanest or most straightforward, okay? All right, let's take a look. We're on to 12. This series of questions refers to this passage. Rocco's going to buy his first car. He works 15 hours each week and saves $10 for each hour he works. Okay. He's already saved $3,500 and plans to save at least $5,300. He knows that there will be an 8.5% sales tax on the purchase and a title transfer fee of $15. He'll use the formula below to determine his gas mileage Y in miles per gallon from the, very similar to the other problem with pressure and the density and G, force of gravity, and H, the height of liquid. These are just telling you what these variables indicate, okay? So don't get caught up too much. We might just need the equation, and looking ahead for number 13, we are just solving for M. Basically get M by itself from this equation, but that's number 13. Let's do 12 first. He will need to pay $5,246.87 for the car. This is your total. Okay. Including sales tax and transfer fee, meaning we needed to pay sales tax plus transfer fee. So the purchase price of the car is the unknown. That's why they're asking for it. Let's call it X. So we need to pay not only the price of the car, but tax. So plus, remember, percents need to be transformed into decimals. So percent, we're going to divide by 100%. Okay, so we're going to move this decimal back here. That's 0.085. 8.5% as a decimal is 0.085. So we're going to do 0.085 times X. Similar to when we were paying tip, but this isn't tip. It's, I guess, tip to the government. We're going to pay tax of 8.5%. And we also need to pay a transfer fee of $15. Okay. And that sum total will be $5,246.87. Okay. There is a number out here that we don't see. It is 1. Okay. So we can rewrite this as, remember, clean things up first. 1.085x. X is the purchase price, by the way. X is car price, not including tax or that transfer fee of $15, plus 15 equals 5,246.87. To solve for X, we need to get X by itself. We're going to move terms first, minus 15. 1.085x equals 5,231.87. And I'm going to bust out the calculator and I'm going to divide by 1.085, which should give me the price of the car. I'm just writing down these numbers. Divided by 1.085. Okay, so grab my handy dandy calculator. 5,231.87 divided by 1.085, and that gives me this figure of 4,822. Very nice figure. Okay. which is answer B. That is X, which is the car price. Okie dokie. And that is number 12. Challenging question, I thought. So try to internalize this idea of tax, and this was the transfer fee. Okay. All right. Using this formula, y equals m over g, we're basically just solving for m, determine the number of miles you can drive. There's a literal equation. One method is we need to get m by itself. It's to realize we need to undo this division by g. So we're going to multiply both sides by g, and voila, these g's cancel, and you'll get m equals g times y, which is answer choice D. Okay. Another way we can do this problem is to make the left side look like a fraction. Why would we do that? So you're going to start with this equation, y equals m over g, and you make this side look like a fraction. Why we would do that is because we could set up, whenever you have a fraction in those fractions, as we've been talking about, you can set up this cross multiplication pattern. So we're going to have m is equal to g times y, which is still answer D. Okay, good job. Which of the inequalities can use to model the number of weeks remaining that he'll need to work before he's saved at least $5,300? Here's the thing. Why is it an inequality? Because he doesn't have to just save $5,300. He could save $8,000. He can save $100,000. He just needs to save greater than or equal to $5,300. Okay, so looking at these patterns, basically A is a good choice and D is a good choice. That on the left side of the expression will be how he's going about saving this money. Okay, but we should be able to save. That's the purpose of inequalities. We want to be able to save greater than or equal to $5,300, because if it's greater than $5,300, he's set. He'll be happy. He'll be a happy camper because he saved a lot of money. Now, which is the right equation? He's already saved $3,500, it says, and X is weeks remaining. How many weeks he needs to go to continue saving up to $5,300? We would not need to multiply 3,500 times X. 3,500 is the set amount, his starting point in his bank. We are increasing the amount of money we save by $150 per week. Why is it $150 per week? $150 doesn't appear anywhere. Yes, but he works 15 hours each week and saves $10 per hour. So he saves $150 per week, okay? Because it's $10 per hour and he works 15 hours. So that's $150 per week. So the right answer choice is, this is not it, 14 is A. Okay. And that would make sense. Moving on. Sample of leaves. Okay. So we have 5 leaves from a tree. These are different leaves. A 6th leaf is added to the sample and its length. Good thing we discussed mean, median, mode earlier. Its measure of this 6th increases the mean, but decreases the median. What is the possible measurement for the length of the 6th? The first thing we want to do is write these numbers in order, lowest to greatest, okay? And that will be 13.4, 13.4, and 13.8, and 14.2. If we just have this 5-leaf sample and we did not add another leaf, okay? They're talking about the mean and median. It's median currently with 5 leaves. The median is the middle number, as I was saying, it's 13.4, okay? The mean I could calculate, I might as well. I don't think it's necessary though, but we will confirm our answer this way, 13.8, 14.2. Easy way to add these numbers. I think there should be an easy way to add these numbers in pairs without a calculator. These will add up to 26. These will add up to 28, but I'm going to use a calculator. Here we go. We have 11.5 plus 12.6 plus 13.4 plus 13.8 plus 14.2. Now 65.5. That is not the average. This, if I divide by 5, the number of leaves, this tells me the 5-leaf average is 13.1. The average for 5 leaves, the mean is 13.1. Okay, so the possible measurement for the length of the 6th leaf, when we do bring in the 6th leaf, we will decrease the median, okay? Decreasing the median automatically implies we have a number that is less than 13.4. When we reintroduce a new number, okay, and if we decrease the median, that means the middle number will be lower once we introduce our sixth leaf. Meaning if we placed it here in order, okay, if we put a number here, we would then find the average between these two and it would be lower. If we slotted the number in here, okay, then you would have 1 number, 2 number, 3 numbers, and then these top 3, you would find the average of these two because these are the middle numbers, and it would decrease the median. This is all to say, the number that you introduce, the 6th leaf, has to be less than 13.4. Okay, so it is not this, it is not this. If the number were exactly 13.4, if you added another 13.4, then there would be 2 13.4s, and the median would be the average of 13.4 and 13.4, which is 13.4. You would not decrease the median as we need to when we introduce the 6th leaf. Okay, that leaves 13.3 and 13.1. The measure increases the mean of the sample. Okay, if it's increasing the mean, which is the average, and the current average is 13.1, we should ensure that we introduce a number greater than 13.1. And so that choice is B. Okay, 15 is B. That would increase, it would decrease the median if we slotted a number 13.3 right here. 13.3. We would decrease the median because the median would now be the average of these two, which is 13.35. And we would increase the mean because this is a larger number. This ensures that we would increase the mean. The mean currently is 13.1. So adding in another 13.1 would just mean the mean would stay the same. Okay, so the right answer is B. A theater showing one movie today only. A media research company randomly selected people coming out of the theater to rate on a 5-star scale the movie they just saw. The results of the survey are shown in the table below. Okay, this is just a sample, and we probably need the total number of people in this sample. This is 20, this is 36, and 36 plus 14 is 50. There were 70 people sampled. Okay, 70 sampled. Which I think was the number sampled in the other one. No, that was 50 people. Okay, so we are just setting aside this number. We might need it in the future. Okay, a total of 325 people saw the movie. Wait, why isn't this 325 people then? Because we didn't ask everyone out of the movie. We just asked a select number of people. Hopefully a simple random sample of people coming out of the theater, which should be representative of how the entire population of people who saw the movie rated the movie. Okay, how many people who saw the movie would have rated with 3 or more? Okay, so you have to understand this sample, which is that's 50 people in a sample of 70. So 3 or more, and this would be total people. This would be people. In this column, we're gonna write the sample, and in this column, we're gonna write the total. Whole theater. And we're just gonna build a proportion again. Like I said, proportions are super important for this section. And so here, 3 or more stars. In the sample, there were 36 out of 70 people. 56. 56 out of 70 people Sorry. 50 people. Okay, you're gonna take this plus this, which is 36, plus this, which is 50 people. 50 people out of 70 people sampled, 50 out of 70 thought would give the movie 3 or more stars. We want to know, the question is asking, based on how many of the people, total people who saw the movie, so that's going to be here, the total number in the theater, would have given it 3 or more stars. And we need the number here, which happens to be 325, of course. That's how many people were in the theater. So how do we make sense of this? You just focus on this. We're building equivalent fractions, essentially. 5/7 of the people, the majority gave it 3 or more stars, right? We could see that, the vast majority. This is 50. These 3 groups is 50. These 2 groups is 20. The vast majority of people like the movie. 50 out of 70 gave it 3 or more stars. So that's a fraction of 5/7. So you want to know, you want this fraction to also be equivalent to 5/7. And that is the key to understanding this problem. But so once we have our proportion set, we're going to solve this via as we've been saying before, whenever you have a fraction equals a fraction, it's a good idea to cross multiply. So we have 70x equals 325 times 50. I'll do our calculator on that. 325 times 50. 325 times 50. That gives us 16,250. 16,250. And to solve for x, we're going to divide both sides by 70. Okay, 16,250 divided by 70. Divide by 70, and I get this number 232 roughly. 232. X is 232. What is x? X is the total from the theater who would give it 3 or more stars. Okay, which is answer choice C. Okay. Alrighty. And this was wait a minute. Yeah, I think I did something wrong here. Oh, no, 16. 16 is C. Okay, moving on. This question. So this question involves a lot of scanning of the table, but we're gonna do this. Vitamin C in 100 grams of each type of fruit. So 100 grams of each type of fruit. Which quantity of fruit contains an amount of vitamin C closest to the combined amount of vitamin C in 50 grams of cherries? So if there are 1,678 milligrams of vitamin C in 100 grams of cherries, how many are there in 50 grams of cherries? Well, that's half the amount. So I would say how much vitamin C is in there? That would be 839 milligrams. This is vitamin C. Okay, I just took 1,678 divided by 2, and I could be more careful with that on a calculator, but I'm pretty sure that's good. Okay, now we also have 150 grams of kiwi. So kiwi, 100 grams of kiwi fruit contains that. So I need to do 50% more than that. So I need to take this and I'm going to multiply it by not 1, because that's the same, but 1.5, because I have 150 grams. Okay, I need 50% increase. So 105 times 1.5 times 1.5, that gives us 157.5. 157.5, that would be milligrams of vitamin C. So that's how many milligrams of vitamin C from kiwi, 150 grams of kiwi fruit. And this is how many milligrams of vitamin C we get from 50 grams of cherries. And so that total, okay, that total will be 157.5. I think that number is, and I need to add 839 plus 839. 996.5 milligrams. That's 996.5 milligrams of vitamin C. And now it's asking us which combination of these fruits would contain roughly 996.5 milligrams. So let's consider first choice, 2,000 grams of black currants. Black currants are here. That's in 100 grams though, in 100 grams. In 2,000 grams, we would need to multiply that by 20. Yep, 20. So the black currants, is that number building a proportion? If I had to explain that, let's go fruit to vitamin C. And we would do these for a bunch of these, but for the fruit, let's say there are 100 grams, we're considering currants. In 100 grams of fruit, there is 181 milligrams. This is milligrams, this is grams. In 100 grams of fruit, for currants only, there are 180 milligrams of vitamins. I am considering 2,000 grams of black currants, 2,000. So what I was saying is the scale factor going this way is 20 times 20, just looking at equivalent fractions. So is 181 times 20 equal to this? No way, no way. Okay, that's much more vitamin C contained there. Okay, so that's not the right answer. Guava, let's move on to guava. That's how many milligrams of guava are in 100 grams of fruit. This is asking us for 800 grams of guava. So I would take 8 times 228. 8 times 228 is not 996. That's going to be over. It should be in the over 1,600 milligrams. Okay. Let's consider the pineapples. 1,800 grams of pineapples. Pineapples is here. Pineapples is also here. And we're comparing it to this. Okay. So that would be 18 times. Let's take a look. So I'm going to create a similar proportion up here. This is for pineapples. We're going to have fruit to vitamins. There's 1,000, sorry. So for pineapples in 100 grams, this is the conversion. In 100 grams of pineapples, there are 56 milligrams of vitamin C. And in 1,800 grams of pineapples, would this be roughly close to this? So let's take a look. The scale factor here, you can eliminate these zeros, is 18. So we would multiply by 18. And we're wondering, is 56 times 18 roughly close to this? And looking at those numbers, they should be 56 times 18. We can confirm with a calculator is 1,008, and that is very close. Okay, that would be 1,008 milligrams of vitamin C. 1,008 milligrams of vitamin C. So I am leaning towards C. I will definitely check D though, and that's 600 grams of strawberry. That's 6 times of this, because that's this is only for 100 grams. If I'm considering 600 grams of strawberry, I'm going to take this and multiply it by 6, and that is not anywhere close to 996.5 milligrams of vitamin C. So I am confident that the answer is C. Okay. A fruit salad was prepared containing 100 grams of cherries, 100 grams of kiwi, 300 pineapple, 200 grams of strawberry. What is the total amount of vitamin C? Not in milligrams, but in grams. Okay, so here we go. We're gonna just add up a bunch of vitamin C here. 100 grams of acerola cherries. That's 1,678 milligrams. These are all in milligrams, mind you. 100 grams of kiwi fruit. We could take this number straight, 105. 300 grams of pineapple. We're going to take 3 times of that. So that's 168, I believe. All of these milligrams. Pineapples, 56 times 3. 8, 1. Yep, 168. And 200 grams of strawberries. So I'm going to double that, which is 118 milligrams. And I'm going to add up all this on a calculator. Let me write down these numbers. 1678, 105, 168, 118. Mind you, these are all milligrams. Okay. 1678 plus 105 plus 168 plus 118. And that will be 2069 milligrams. Okay. 2069 milligrams. Now, if we're converting milligrams to grams, grams is a larger unit, so we need less of them. We need less of them to be equivalent. And milli, if you recall from science, involves 1,000. So you need to move this decimal 3 places to the left because we need a smaller number of grams because it's a bigger unit. So 1, 2, 3. So we're looking at 2.069 grams, which is answer choice B. D is also tempting, but 2,069 grams is much heavier than 2,069 milligrams. It can't be, if you got 2,069 milligrams, it can't also be 2,069 grams. 2,069 grams is a lot. Okay, so the right answer choice is B. Okay. Okay. 0.25% of TVs are defective. If the manufacturer produced an average of 450 TVs, which of the following is the best estimate of the total number of defective TVs produced in 30 working days? Okay, so I think the first thing is understanding that this needs to be converted to a decimal. You might be saying it is already a decimal, but it's still a percent. So this is 0.25%. Converted to a decimal, this is equivalent to 0.0025. 0.0025 of, that's multiplication, all TVs of, that's multiplication, all TVs are defective of TVs would give you the defective number. So if you just simply calculate all the number of TVs produced and multiply it by 0.0025, we will find out how many were defective, okay? So we need 30 working days. There's 450 produced each day. So we're going to take 450 times 30. That 450 times 30 tells us how many TVs were produced in a month, 13,500. Oops, 13,500. This is TVs. Like I said, we would then take this percent, which this decimal number is 0.25%, which is 0.0025, and multiply it by this number, which is how many TVs, to find out how many defective, because it's a proportion of how many defective. So I'll take that times 0.0025 times 0.0025, and I will get a number of defective TVs, which is roughly 33.75, which rounds up to 34, and the right answer is B. Okay. All right. Zipping along, guys. 20 is a really good question. I thought a few remarks about this line. Its slope is positive because it increases from left to right, and its y-intercept is negative. Okay. Now we don't actually have to find the numbers, so it is in the form y equals ax plus b. A is the slope, so A is positive, B is still the y-intercept, B is negative. So which of these are true about A and B? This statement A, this implies A is positive. It's between 0 and 1. Okay, that satisfies this. And B is negative. If B is negative, it would be less than 1. So this would be true. Okay, there are B's that are not negative that are less than 1, for example, 0.8. But if RB is negative, which it is, okay, RB is negative, if we slide in a negative number there, it will make that inequality true, okay? If we consider B is out of the question already because this first statement is saying A is a negative number. A is not a negative number. A represents the slope of this line, and the slope is positive. Okay. B would be a true. B could be a true statement. Sorry, it could be greater than -10, but not all numbers are. Not all negative numbers are. Not every number Not every number that's greater than -10 is a negative number, but that's neither here nor there. B is already wrong. C is also wrong. A has to be positive. D could be right based on this first statement, but B is not. We already know B is a negative number. So that leaves our right answer choice of A. That again comes back to an understanding of slope-intercept form. Okay. All right, 40. He pays $25,000 to buy a new truck. He estimated the value of the truck after 5 years. So this is year 1, 2, 3, 4, 5. Each and every year, his truck value seems to be decreasing by, we can see a pattern, minus $3,000. Okay. If the line passing through, if we had to graph this, 1, 2, 3, 4, 5, we have these numbers, 10, this will represent a break. Okay, so this isn't necessarily jumping from 0 to 10,000. This is money in thousands, and this represents the value of his car. This is 10, this is 13,000, this is 16, this is 19, this is 22. At 1, we're at 22,000. At 2, we're at 19,000. 3, we're at 16,000. 4, we're at 13,000, and 5, we're at 10,000. Mind you, like I said, this is a break. We can't jump to 0 to 10 to scale. Okay. Notice this is very close to, it actually is a linear relationship. It's just my sketch is off because we know each and every year it goes down by 3,000, 3,000, 3,000, 3,000. It goes down by. If the line passing through the points defined by the values in the table is graphed in the XY plane, we made a sketch, which is the best interpretation of the y-intercept. The y-intercept would be right, would be right up here. Okay, it would be up here, above 22,000. 22,000 is right here, that's why. So if we it's like backing this up one step. Okay, we would have a y-intercept of, this is just a sketch, of 25. And we already know what that number is. It says he sent 25,000 to buy a new truck. It would also be the cost, the price, the value of his car in thousands when the car was 0 years old. It was when he got it brand new. So it will be, the following is the best interpretation of the y-intercept. That is here. That will be the value of the truck when it was new. Okay, just FYI, A, the number of years which value will decrease, the number of years, that's a bunch of years. B, the amount of value that the truck is decreasing each year, this would be the, you guessed it, the slope. Okay, that would be the slope, how much it's decreasing each year, which is 3,000. Okay, good. And now for the open-ended ones. Okay. This is, again, a system of equations. We've talked about a system of equations from this first section. One method to solve a system of equations is elimination. I think this is best suited for elimination because this is in standard form. The x's and y's are aligned. The first thing we're going to want to do is probably multiply equation 1 by 2. And yep, we're going to do that here. I'm just thinking ahead to this problem, what I would want to do. Yeah, we're going to multiply that by 2. Okay, I could flip these equations around, but that's not necessary. So we're going to multiply everything by 2. And equation 2 will look like this. Equals 1.6. Okay. The first thing we have to do is not just automatically cross these out. Okay, guys, we're going to choose an operation to eliminate these two. The operation of that is, since these are exactly the same, we are going to subtract. So make sure you subtract everything. Okay, everything has to go through this operation. So we have negative 12y minus 7y, that's negative 19y. And if you have 5.4 minus 1.6, that's 3.8. Okay. After you divide by negative 19, these numbers look kind of a little strange, but these are correct. 3.8 divided by negative 3.8 divided by 19. 3.8 divided by 19, and I know the answer is negative 3.8 divided by 19. I will get 0.2. So the y value is negative 0.2. However, I can't stop there because it wants us to find the x. So at this point, I'm going to choose what I think is the easier equation. I think the easier equation is 2, but it does not matter. You could plug it into either. So here's my equation 2. I'm going to plug this value of y into that for that in equation 2 and solve for x, because that's what I really want. I want x. So 10x minus 1.4 equals 1.6. So 10x, right. I'm going to add 1.4 to both sides equals 3. And so my x is 0.3. And you're going to bubble that in. You don't need the 0 in front of the 0.3. Okay, you just bubble in 0.3. Okay, all right. And we're almost done, guys. Oh yeah, there's some bubble instructions right here. Notice there, notice for these samples, there are no zeros before the decimal. You won't need one. Also, I want to draw your attention to this. No question has negative answers. So in case we got a negative answer for x, something went wrong. Okay? All right. This question is really great. It's a good system of equations, and the trickiest part about this question is right here. There are couple tickets, and this is not tickets though. There's 130 people, and we'll come across that soon. So what do we need? We need, what's unknown is, how about x, s, and c? Let's use s. S is the number of single person tickets, the number of single person tickets, okay, sold. C is the number of couple person tickets sold, okay? So let's start making some equations. One equation will have to do with money. And so let's make that equation. That would be 200x. That's how the tickets for one person, okay? I'm sorry, S. So if I sell a single person ticket, if I sell one single person ticket, I'll make $200. If I sell 2 single person tickets, I'll make $400, okay? Plus 350 times the number of couple tickets sold, that should give me the money brought in from selling couple tickets, and this will equal 24,000. But that's only one equation. That's the thing, guys. If I'm trying to solve a system of equations with 2 unknowns, and there are definitely 2 unknowns here, I need 2 equations, okay? So what is my second equation? I think the most common mistake for this is to say S plus C is 130. The reason why this isn't the right answer is because S is the number of tickets, C is the number of tickets, 130 is the number of people, okay? So here's the thing. If you sold a single person ticket, we can assume one person is coming from that, okay? This, in other words, this equation right here has to do with persons. It has to do with people. So the number of single person tickets will be the same as the number of people who come. But the number of couple tickets sold will not be the same number as the number of people who come, okay? If you sold one couple ticket, that implies that 2 people will be coming to dinner. And that is the key to solving this problem, okay? I think the easiest way, the number of tickets, what is the total number of tickets sold? We need S and C in this case. So I was just looking which I want to eliminate. Maybe I could save some time, but we need both S, the number of single person tickets, and C, the number of couple person tickets. Since the system of equations, we're gonna, I want to leave my answer positive. So I'm gonna multiply equation 2 by 125, okay? So equals 24,000. Okay, and I'm going to multiply equation 2 by 125. This will match the C values. So I have 125S plus, no, wrong number, 175. 175S plus 350C equals 130 times 175. 130 times 175. That would be 22,750. 22,750. I will choose the operation, and that operation will be subtract because these are exactly the same, we subtract. So I will have 25S is equal to, that's 1,250, I believe, and I'll divide to solve for S. 1250 divided by 25. 1250 divided by 25, which tells me I sold 50. I sold S, which is the number of single person tickets. S is equal to 50. Yep, that was the number I got. And so that's the thing. I'm going to use either one of these equations. I'm going to roll it back to the second equation, which was S plus 2C. That doesn't imply I sold 80 couple tickets, right? I didn't sell 80 couple tickets. 80 couples showed up to round out my 130. I'm sorry, 80 people, additional people showed up to round out my 130. Okay, because 130 total people showed up. 50 singles showed up because that's how many single tickets I sold. So that implies that there are 40 couples tickets, but I will show you the equation. 2C, 50 plus 2C equals 130. That implies that 2C equals 80, and that implies C equals 40. C, mind you, is the number of couple persons, number of couple person tickets, number of couple person tickets. So I sold 50 single tickets, 40 couple tickets, and the total number of tickets that were sold were 90 total tickets. That's the sum of this and this. Okay, and that's that. Okay, last question, guys. The Senate, 44 women. While going through this problem, my only advice is don't panic. If you can't complete the whole table, maybe it wasn't intended to be completed. So think about that, okay? We might not need to complete everything right away. We might not be able to complete everything right away to solve some of these problems. You might be able to solve some later as more information is given, okay? But from the initial given, you might not be able to fill in everything, and that's gonna be okay. Total of 44 women served as U.S. senators. Partially completed table. And we are not, from what we have, are able to complete it fully yet. Okay, and so don't panic. We can fill in certain gaps though. Okay, if you took some time to fill in the table, we could fill in these gaps. And let's just do that right now. This will be 4, and this will be 1. We can also fill in this right off the bat. This column right here. Okay, and those are Republicans, and we can get the total number of Republicans, which should allow us to find the total number of Democrats because we know the total women who served as senators was 44. So this adds up to 11 plus 3, 14 plus 1, that's 15. And this number has to be 29. Okay, and that will help us much later in the problem, but we know all those things already. And notice, like I said, if you can't go any further, don't panic. What's the total number of women from the Democratic Party, so we're here, who served as U.S. senators from 80? So this number is going to be 29. That's how we got that. Okay, these two have to add up to 44. So I did 44 minus 15 to get that. So we already know 24. The answer is 29. And here we go. We need additional information to get these, okay? There's no way we can get those without any additional information, and this is going to be the information given. In these years, the women from the Democrats who served as senators, 34.5% were from the South, okay? Of all the women from the Democratic Party, that would be of all 29, okay? And we, once again, convert that to a decimal, so the 0.345. And we're going to multiply that by 29, and that will tell us how many from the South. 0.345 times 29. 0.345 times 29. And that's a fraction of a person, but it is close to 10. And that's how many serve from the South. Notice that's not the question, though. What is the total number of Democratic and Republican women who represented Midwest? And what we need to focus on is right here. Okay, and we need the total number of Democrats and Republicans. So we need that box right there. Okay, but to do that, we need this. And to do that, we would need to come up with, I see that these already add up to 20, but there are 29 total Democratic women. So this should be 9. And the right answer here is 16. Okay, and that was last. Guys, good luck on the PSAT. feel free to ask your kumu for kokua, or email or leave a comment if you saw anything a little off. All right, thank you so much. Good luck.